Over 2 days, we'll witness presentations across 6 technical tracks covering IoT, big data and cloud systems, image and video processing, artificial intelligence and advancements, electrical systems, wireless networks and antenna microwave technology, and intelligent computation and smart systems. We thank all authors, reviewers, and participants for their contribution and engagement. That was a soulful and mesmerizing performance of invoking the blessings of Lord Ganesha for enriching our gathering. We have the privilege of welcoming our distinguished guests who have graciously joined us today. Chief guest Professor P.C. Pancharia, Director, CSIR, Central Electronics Engineering Research Institute, CD, Pilani. Honorary Chair Professor Valentina Amelia Balas, Faculty of Engineering, AV University of Arid, Romania. Conference Chair and Keynote Speaker Professor Dr. Ravikumar Arya, Zhongshan Institute of Changchun University of Science and Technology, China. Guest of Honor Dr. Ankit Agarwal, Research Professor, Department of Electrical and Computer Engineering, McCormick School of Engineering and Applied Science, Northwestern University. Session Chair Dr. Basant Agarwal, Associate Professor, Central University, Rajasthan. Honorary Chair Dr. Poonam Gera, Associate Professor, Computer Science and Engineering, LNM IIT Jaipur. Natasia Badnava, Specialist of JSC Giprosivis. Nicole Yunevich, Researcher of JSC Giprosivis. As we begin this auspicious occasion, we invoke the blessings of Goddess Saraswati, the embodiment of knowledge, wisdom, and creativity. With lamp lightning, we symbolize the dispelling of darkness and the illumination of our minds, seeking her divine guidance and inspiration for the pursuit of knowledge and innovation. We request our guests to please come on the dais for lamp lighting. We request Professor P.C. Pancharia. we request Dr. Balwan Sheshma, Registrar PIET, to present a shawl to Chief Guest Professor P.C. Pancharia as a token of respect. Thank you, sir. We invite Dr. Sama Jain, Head of Department Applied Sciences, PIET, to present a shawl to Guest of Honor Dr. Ankit Agarwal. Thank you, sir. Thank you, ma'am. Thank you, ma'am. Thank you, sir. Now, we shall invite our conference chair, Dr. Budesh Kavar, Head of Department Artificial Intelligence and Data Science, PIET, to address the conference report.
Very good morning to all the dignitaries, distinguished chief guest, Professor P.C. Pancharia sir, honorable guest, Dr. Ankit Agarwal sir, Valentina Balas ma'am, honorary chair of the conference, Dr. Ravi Kumar Arya, conference chair, our keynote speaker, Basant Agarwal sir, session chair, Poonam Gera ma'am, respected dignitaries, esteemed researchers, faculty members, and industry professionals, and dear delegates to Second International Conference ICRACS. It's our great honor to present conference report for Second International Conference on recent advances in artificial intelligence, computer vision, and smart systems, that is ICRACS 2025. Organized by Department of Artificial Intelligence and Data Science at Punima Institute of Engineering. It is the first conference after our NEC A grade, which we have received last month only. If I talk about ICRACS 2025, we have received overwhelming response from the global academic and research community. We received total 259 paper submissions in the domain of AI, computer vision, smart system. After the rigorous and double-blind paper review process by 258 expert reviewers, and we have selected 55 high-quality papers which has been accepted for presentation as well as further processing, ensuring the academic excellence and innovation. We are pleased to welcome participation from 4 countries with 55 registered delegates, including students, academicians, industry professionals, a promising, dynamic, and enriching exchange of knowledge. The conference will feature with a total 5 technical sessions. Today we have one offline session which will held in Sirohi Hall. So all the offline presenters will be going there. 4 online sessions will be conducted, 1 today and 3 online sessions will be conducted tomorrow. These sessions will be guided by 9 session distinguished chairs and are coordinated by 10 dedicated faculty members, ensuring effective moderation and engagement throughout the conference. If I talk about publication, all the accepted papers of our conference will be published in AIP conference proceedings, which will be indexed in Scopus, guaranteeing the global visibility and academic recognition. I extend sincere gratitude to the organizing committee and the technical committee for their diligent planning and commitment. Their collective efforts and working together laid a strong foundation for the successful conference. Over the next 2 days, we look forward to insightful presentations, academic discussions, and collaborative opportunities that will further research and innovation in the field of AI and smart systems. We invite all the delegates to participate actively and contribute to the success of ICRACS 2025. I again thank you all the dignitaries and respected members for making this event a grand success. Thank you so much.
Good morning, everyone. आवाज नहीं आई. Good morning, everyone. That's better. We need energy to speak also and to deliver to you also. I, first of all, from core of my heart, welcome Dr. P.C. Pancharia, sir. He has been quite generous to spare his valuable time. He has to travel from here directly to Delhi for a meeting. But just on a phone call, he has agreed to chair the ceremony of second ICRACS, which is being organized by Department of AI and Data Science at PIT. So my heartfelt gratitude to him, sir. I extend welcome to Dr. Valentina and Dr. Ravi, those who are joining online. They have been pivotal in shaping this conference. My gratitude towards Dr. Ankit Agrawal, sir, guest of honor. He is traveling all the way from US. Dr. Basant Agrawal, sir, from Central University, Rajasthan, my old friend, and his two co-researchers, Nicole and I don't know other name from Belarus. I welcome all of you. All the session chairs, starting with Poonam Gira ma'am and other experts from MNIT, Bhopal, Triple IT, Una, and many other premium institutes across the country, and all the participants. This conference, the second edition of this conference, is an outcome of research efforts of various scholars who are discussing their research in AI, computer vision, and smart systems. I hope these deliberations of next 2 days will be a learning towards the society and will provide new dimensions of research to all the researchers across the globe. Post publication of these papers, the papers will be accessible to all the users. So we can get tomorrow we may guide some new technologies being implemented on these papers also. With these words, I welcome all of you and thank you, Budesham, and all team members to work on this conference. Thank you, everybody.
Thank you, sir. It's our privilege to welcome our honorary chair, Professor Valentina Amelia Balas, a renowned expert in intelligent systems and soft computing. With over 30 years of experience, she teaches and supervises students at AV University of Aaron. Her research focuses on artificial neural networks, machine learning, and fuzzy logic. She is a certified peer reviewer and has published numerous papers in esteemed journals and conferences. We welcome you, ma'am, and now I would like to request you, ma'am, to please embrace the gathering with your enlightening words.
Good morning to all of you, and thank you very much for the introductions. Good morning, dear esteemed delegates, participants, and distinguished guests. I am truly honored and delighted to join you as the honorary chair of the second international conference on recent advance in artificial intelligence, computer vision, and smart systems. This conference is taking place at the Purnima Institute of Engineering and Technology in Jaipur. Distinguished guests, esteemed colleagues, respected members of the organizing committee, dear researchers and students, it is with immense honor and heartfelt gratitude that I address you today as the honorary chair of your conference. I would like to begin by expressing my sincere appreciation to the organizing team for inviting me to be a part of this significant gathering. This commitment to scientific excellence, inclusivity, and innovation is not only admirable, but also essential in a world that increasingly relies on technology to solve its most complex challenges. This conference is more than just an academic event. It is a celebration of human intellect, of tireless inquiry, and the remarkable progress we continue to witness in the field of artificial intelligence, computer vision, and smart systems. These disciplines no longer belong solely to the realm of theory or isolated research. They are the heartbeat of modern innovation, shaping industries, influencing policy, and transforming the way we live, interact, and dream about the future. In recent years, AI has become ubiquitous, powering recommendation engine, assisting in medical diagnostics, enabling autonomous vehicle, and even creating art. Meanwhile, computer vision systems are giving machines to ability to see, to understand complex sound, to interpret human expression, and to monitor environments with unprecedented precision. And smart systems at the intersection of hardware, software, and intelligence are leading the way in building sustainable cities, responsive healthcare systems, adaptive manufacturing, and secure cyber-physical networks. But with great power comes great responsibility. As scientists, educators, engineers, and visionaries, we are entrusted with the profound task of ensuring that the technology we develop are ethical, inclusive, transparent, and human-centered. We must build systems that do not just optimize performance, but also uphold fairness, accountability, and trust. This conference plays a vital role in this endeavor. It provides a platform where scholars and professionals from across the globe come together to exchange ideas, share research outcomes, pose critical questions, and explore new frontiers. Such events are the bedrock of progress, enable collaborations that transcend geographical borders and disciplinary boundaries. I am especially encouraged by the strong participation of young researchers and PhD students at this conference. Your curiosity, creativity, and drive are the fuel for future discoveries. I urge you to take this opportunity to engage, to question, to learn, and above all, to believe in the transformative power of science when it is guided by purpose and patience. Let me also acknowledge the outstanding contribution of our keynote speakers, session chairs, reviewers, and technical committees members who have generously devoted their time and expertise to ensure the highest quality of this scientific forum. Your dedication upholds the standards of excellence that define international research. As we embark on this journey of knowledge exchange, let us remain open to new perspectives. Let us listen not just to present solutions, but to the unspoken needs of the future. Let us debate with integrity, collaborative empathy, and dream with ambition. We are now in the Holy Week for us Christians, the week of Christ's Passion. But just before Easter, next Sunday will be Easter for us, both Orthodox and Catholics, a time of reflection, sacrifice, and renewal. As we gather here to explore the future of artificial intelligence and intelligent systems, let us also take a moment to reflect on the values that guide us: compassion, purpose, responsibility, and hope. This is not only a season of spiritual significance for many around the world, it is also a reminder that true innovation must serve humanity. Whether through technology, science, or faith, we are all seeking meaning, connection, and better future. Let this conference be not only a celebration of scientific progress, but also a space where we remember to build, to help, to support, to upfit, and to create a smarter, more human world. As we explore the cutting edge of artificial intelligence, computer vision, and smart systems, we must remember that technology should not distance us from our humanity, but deepen it. In the words of Leonard Sweet, he said, Christ does not say to me, be yourself. He says, be with me. This powerful message reminds us that identity, growth, and purpose are not found in isolation, but in connection with others, with our communities, and for many with the higher purpose. Likewise, as researchers and innovators, we are not called only to develop machines that think, but systems that understand, that serve, and that connect. Let this quote serve as a reminder: the smartest system is not that makes us more human, nor less. In closing, I would like to leave you with the thought that resonate deeply with me, especially in the context of this conference. It's the same Leonard Sweet. The future is not something we enter. The future is something we create. Let us create the future together through science, innovation, and shared purpose. I warmly welcome you once again to this important conference and wish you a fruitful, inspiring, and truly memorable conference experience here in Jaipur. Thank you.
Thank you so much, ma'am, for your enlightening words. It is our distinct privilege to welcome our chief guest, Professor P.C. Pancharia, Director,
Anyway, at the end,
CSIR,
I would like
Central.
to express my appreciation to Professor Dr. Dudesh Kanwar, Head of Department of Artificial Intelligence and Data Science. She was always with me, writing many times, and I want to send my sincere thanks for the kind invitation and for maintaining our valuable connection. Thank you.
Thank you so much, ma'am, for your enlightening words. It is our distinct privilege to welcome our chief guest, Professor P.C. Pancharia, Director, CSIR, Central Electronics Research Institute, Siri Pilani. His illustrious career and visionary leadership at CSIR Siri have significantly contributed to scientific research and technological advancement. We look forward to gaining from his wealth of knowledge and experience. So, we are deeply honored to have you with us today. We now invite you to grace the stage and share a few words with us.
Very good morning, all. First of all, I thank Professor Dinesh Goyal for inviting me for this international conference on AI, machine vision, and smart systems. All the dignitaries on the dais, Professor Ankit Agrawal, Professor Basant Agrawal, Professor Gera, all the faculties from PIET, all my students, guests from Belarus, all the guests who have joined online. Thank you very much for inviting me in this conference. It is great pleasure and honor for me to be part of this conference. Friends, this conference is organized at the right time because we have a vision. Now India has a vision. It's a vision to change the nation. We have a vision 2047. We need to be a developed nation. For a developing nation or developed nation is a big difference. We are a developing nation and we want to be a developed nation. It's just not a slogan. Each and every citizen of India supposed to work towards this vision 2047. And without science and technology, it is not possible. And the recent topic of this artificial intelligence, smart systems, and computer vision is one of the emerging fields which will make our nation the great nation, the developed nation, and this is essential. Friends, AI is not a new subject. AI started in 1940. So the concept of AI, it was like whether computer can do the things which human can do. This idea was the AI. And later on, in 1956, there was a conference in Dortmund where the artificial intelligence, this term was coined. And then initial 20-30 years, there was no such big progress in artificial intelligence. Even in 90s, people could not apply artificial intelligence in systems, in machines. I started my AI work in 90s. I completed my master's in 1994. I'm not from the computer science. I did my master's in physics and did my master's MTech in instrumentation. Then I joined as a scientist in Pilani. My first task was, at that time there was no computers at all. So 94, the globalization started in India, and my first task was to automate tea industry. So industry is like you have to apply computers. The reason was that all the machinery work was done by the manual. So that was a big challenge that industry should go adapt a new technology. And the task was given to me was the tea quality estimation. Still it is not there. So what people do when you say it's quality estimation, it's normal tea which we take. So how to estimate the quality of tea? So there are testers, tea testers, they are called tea testers. And there is normally a panel of testers. 20-30 testers are there. And everybody, test it and then give the mark. The mark is based on color, the flavor, and the liquor. So there are three things are there. One is color, the flavor, what odor it is coming, and the taste, what is there. So you know that if you have any biological material, say there are flavors is coming from the volatile compounds, and there are few things which is non-volatile. So that is called taste. So how to mimic this taste? So what you need? For eye, you require a camera. You can estimate color. For taste, we have taste buds, we have tongue, and then smell, we have a nose. So if you want to make an artificial tester, you require three things. One is camera, one is nose. It should be an artificial nose. You require a tongue, artificial tongue. So that was the challenge. And I was just passed out from a master program, and we had a limited knowledge that what to do. So reason why we are going for artificial tester. When we were estimating the quality, so every time whenever we used to send to the sample to testers, so sometimes they give 10 marks, sometimes 5 marks, sometimes 2 marks, and whole year I used to take data, and after a year I found that there is a variation of 60% variation. So the machine was the only answer. So I decided, okay, what to do. Then we did the mathematical analysis, statistical analysis, and there was no solution at all. Then we decided that, okay, we will make artificial tongue, electronic nose, and then vision-based scalar measurement. But I could not, because I didn't know about this field. So that time, fuzzy logic, neural networks, this field started. So then I started, okay, if I apply this field into artificial testers, development of that system, then I can solve this problem. So in that way, I started my AI journey in 1995, and in 2000, I did my PhD in AI. So at that time was completely different than present you have. The research topic was, if you use a fuzzy logic, then it should be a transparent system. Your system should be, your algorithm should be computationally simple, because there was no computational power. And you apply GA, genetic algorithms, evolutionary algorithms, then you used to compute, and it used to take one whole night for small algorithms. So at that time I started this research. After completing my PhD, I come back from Germany to India, and I used to explain my colleagues that, okay, this is a field and we can apply this AI in different systems. Even when you talk about fuzzy, the people used to say it's fuzzy. It's not a fuzzy logic, it's a fuzzy logic. Neural networks is highly complex, because there is a hidden layers, there are neurons. Nobody knows what is going in a black box. So then neurofuzzy come, which you have a fuzzy and you neural network, use best of these capabilities and then make a neurofuzzy systems. If there is a problem, then you apply genetic algorithm, or you can use evolutionary algorithms. So interesting thing was that once I come back, and then I told my director that, okay, this is a very recent field and we can make a system in this one. Then he said, okay, if you want project in this, then you have to take a project from, funding agency, and then approve that, okay, you can do the work. So what happened? At that time, I applied a research project on electronic tongue, AI-based electronic tongue, and AI-based electronic nodes. I presented the proposal. Interestingly, the committee first time they seen that, okay, electronic nose is good, electronic tongue is good, but you remove this AI, because we don't want this AI in this proposal. If you want to work, do it, but don't show in titles that AI should be there. So that was the condition in 2000. Now I am same member of that committee And I see that without AI, they are not sanctioning projects. So this was a scenario at the time. And we struggle to get project if you are putting AI in your project proposal. Finally, we develop electronic tongue, electronic nose. And you know that nowadays, all these food products like milk, ghee, dairy products, edible oils, essential oils, okay, there is adulteration everywhere. So what to do? If you use classical methods, it's not possible to detect adulteration. But we take milk every day, but you know, there is a chance of adulteration of urea, salt, detergent, caustic soda, lot of things. If you use traditional method with AI, then you are able to develop the system. I have a number of technologies in market. We use AI, but we don't tell it is AI. Because at that time there was no fascination of people, or they don't, if you say it's AI, then they say it won't work. You keep it. So we won't take technology. But nowadays, now this use of GAN algorithms, I think the AI become most popular, because when you're writing some emails, the whole sentence is coming to you, and then okay, you just have to click it. So this is assistive mode. And AI is always a assistive role. Whether all people say that okay, this AI will be, you know, like they will take a job. No, it is not possible. Because this is ultimately artificial intelligence. It's not a human intelligence. So nobody can replace human intelligence. We are just mimicking the human intelligence. And they cannot overcome with the human intelligence. So whatever the algorithms, because we have to teach them. If you teach a child a banana to an orange, he will speak orange. AI is like that. So human intelligence will be always upper hand. There won't be any chance of losing a job, or your mode will be different. You will call the prompt engineer or some else engineer, but there is a requirement of manpower. Speed may increase, our productivity will increase, but our usage of human manpower, it will not be replaced. So don't think that okay, if you use AI, then we will lose a job or we will have a dangerous. Nothing is there. गौरव टावर बना आपके यहाँ पे, तो क्या आसपास के किराना की दुकानें बंद हो गई? नहीं हुई ना. ऐसा है, एआई कुछ भी हो जाए वो चलेगा. But when you are a researcher, and I want to, you know, like give a suggestion, use AI in your algorithms, systems, but don't blindly use them. Now deep learning is there. So what we do, we take Python tools or MATLAB tools, just blindly just training a system. But this is not the way. You have to implement your own codes, your own tools. Because nowadays, if you think that okay, your mobile can do a lot of things, there is a GPU. So we are going behind the GPUs. So whatever the code it is available, we just take it and run the program. How much power it is consuming? What is the computational cost? There are two things you have to remember. Whether it's highly computational expensive. So you have to make your code optimize. When you optimize it, then you will go into the deep. You have to change the mathematics. So can you apply AI in a 8051 controller, very smallest controller, which costs 20-30 rupees? Because we don't use, we directly take libraries. There is OpenCV, whatever it is there, you keep it, put in your algorithms and run it. But you don't think that okay, how much cost it is paying. So all the researchers, my request is AI is not a solution for all the diseases. It's not a remedy for all. Keep your fundamentals clear. First, statistical, mathematical fundamentals. Then, top of it, you can use AI. If you scratch from AI, if you are training a model, it won't be a successful model. So, make a mix of them. Take mathematical model, make a statistical strong models, analyze this, and then use AI as a top up. So then your model is 100% successful model, and what you are doing, you will achieve it. From these words, I take my place. Thank you very much for once again inviting me. Thank you very much.
Thank you so much, sir, for insightful words. Now, let's welcome Professor Dr. Ravi Kumar Arya, a distinguished professor and director of the Jiangshan Laboratory Wireless Group at the Zhongshan Institute of Changchun University of Science and Technology. With a PhD in Pennsylvania State University and experience in academia and industry, Professor Arya is a renowned expert in antenna design, computational electromagnetics, and machine learning applications. He has published over 80 technical papers and book chapters. We are truly honored to have you here, sir. Now, I would request you, sir, to please address the gathering and share your insights with us.
Am I audible?
Yes, yes, yes,
sir.
yes.
Is the screen visible?
Yes.
Okay. So, as others have already described, just a minute. Okay. So, thank you very much for the invitation, and it is my honor to be present here in International Conference on Recent Advances in Computer Science, and that is being held in Purnima Institute of Engineering and Technology. And I'm very thankful to Dr. Saurav Raj, Dr. Kanwar for keeping me updated with this conference. And our topic of, yes, our topic of discussion here is from digital to physical, AI, 3D printing, and smart measurement for next generation wireless systems. So, like other guests also discussed earlier, that as more and more research from AI is moving into different domains, so here we would be discussing that how 3D printing and measurements or antenna design or wireless systems, how they are getting integrated with AI. So just to go to the background that where we stand today, currently this is our status that if to any chatbot like maybe Gemini, here we have, if we tell it to generate an image of futuristic car driving through an old mountain road surrounded by nature, so it would be able to make a picture like this. And the research as we other areas are also getting integrated and trying to get benefit from AI. So there's a similar work that is parallelly happening into wireless domain or antenna domain. That is my research area. So is it possible that we can also use this type of chatbots for making electromagnetic designs? So if this type of work does happen, so we would have something like this. That like we had a prompt where we told to generate an image. The similar work would be there, like where we can tell the chatbot that design a microstrip antenna with these specifications, and we would be able to get the output like this. There has been recently there has been a lot of work that is getting pumped, like the data is getting pumped, or the 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 company that are working with simulation tools, they have already started that work. Last year, we saw that ANSYS started with Sim AI, and that uh, ANSYS being a leader in simulation softwares. So they have already started to embed the data that is coming from the simulations, so that the AI can be very responsive to give us the designs. Similar work is going with COMSOL Multiphysics, the other simulation company, and there also they have like you can use the chat gpt from OpenAI, and you would be able to make the designs. So just to appreciate that where do we stand, that which type of problems we are able to solve in antenna engineering or similar domain. So let's assume that this is the, I tell that to the system that this is the pattern, the radiation pattern. Normally what happens when we have number of antennas, then we would, with the combination of these antennas, we would get a radiation pattern. Like radiation pattern tells us that uh, how the energy would be distributed around the antennas. So what we can have is that, let's assume in a particular area, we want a particular type of pattern, that here the energy should be high, here it should be low. So that type of input can be, if this is given to the system that is trained, then after deep learning, we can get the output, something like this, where it would be able to give us that this should be the design. So it's like inverse designs, where we tell us, okay, this is the output we want, and tell us now that which type of distribution of the antenna should be there, that would be able to give us closest to this pattern. So this was the input pattern that we gave, but ultimately this is the output of the antennas. And after deep learning, we would be able to get this result. So similar work is going on. Like so, another example is like, let's assume you have any product. So similarly, we also have antennas, and in antennas we have like they give us, okay, this is the radiation pattern. This is one cut. This is another cut. So indirectly, there is no full information. There is a 3D pattern, something like this. But in the when we have the data sheet from the antenna, only two patterns are given. So it's like, okay, where the green color is, we get a cut like this, and another there is a cut like this. So only these two cuts are given. But we do not know how the 3D pattern looks like. So recently, MathWorks, the company behind MATLAB, they also started to use deep learning in order to guess like what would be the 3D pattern, something like this, that would be able to generate the 2D pattern like this, that is given in the data sheet of the antennas. So now from the data sheet of the antennas, we would have these patterns, and we can guess that exactly that how closest it would look like. So this is the 3D pattern that can be created by using AI. Last year, we also started some work on AI. Basically, we are working for some time, but we proposed that there can be AI-based antenna design software that would be similar to ChatGPT, and its job would be that it would be able to uh, design the antennas, something like this. Like we called it antenna guru. So it starts like, okay, welcome to guru, please say hello to get started. So once we say hello, then guru would start asking, we start giving the prompt that this is what we want, and ultimately it would be able to design antennas. And similar type of chatbots or even the agents, like we would have AI agents. Their job would be like for a particular specific task, we would be able to, they would be specially trained to work on a particular domain in which they have been trained. So similar thing is already multiple research groups are working on embedding the AI, the benefit of the AI into their own research domain. So here we are working on antennas. So just to get a better grip of where do we stand, how AI can be helped. So let's assume this is the design that we made one antenna and there were some dimensions of this. These are just take them uh, uh, the copper that has been printed on the laminate, like FR4 sheet or something like that. So what might have happened that let's assume I made one design, and when I made the design, I knew what would be its output, like from which frequency to another frequency, which within which frequency band it would work. So I knew that because when I designed it, so with those parameters, I designed it and then I fabricated this design. But what might happen that there might be some problems, something like fabrication. There might be imperfections where the fabrication, instead of making it 2 millimeter, it might be 3 millimeter. So there might be another issues that okay, the laminate that I use that might not be the right laminate, or there might be the SMA connector that I use that might be wrong. So the thing is that there is a possibility that the result that I wanted from this antenna it will not be right. So what we did in this work, that let's assume I have made this antenna, but is it possible that after fabrication I go back and will it be possible for me to know that what was the error? Whether this length instead of 2 millimeter it became 3 millimeter. So what we did that okay, that if we have very good measurement tools, then after the design has been fabricated, then also we would be able to go back and basically look from where this error might have come. So let's assume that this K value, that from here to here, if this K value got changed, we would be able to know that how much fabrication fault might be there. The thing is that just now we cannot appreciate this enough because here we can look at it visually, we can measure how the problem, how much difference might be. But if it is a multi-board, that there are multiple sheets that are embedded together, so then it becomes really difficult to know. After fabrication, if there is any problem, we would be able to know that where exactly the problem came from, whether it was fabrication so that we can improve the fabrication, or any material got changed or anything happened in the design. So now, so basically what exactly we do is that let's assume that this was, just now we are only showing that let's assume there were two parameters that got changed. I would be able to find out that exactly what associated value of K and G is when I measure that, when I measure the data. So for this measured data, there would be some K and G values that AI has to find out that is closest to this measurement data. So indirectly, if the measured, the value that we got from the measurement and the value that has been used for simulation, if they are not same, then I can say that K and G values are wrong, right? If they are same, then it means there was no problem. But if they are different, like here we can see there is some difference, here it got changed, right? So at least here we see the difference. So with this difference, we can come to know that what was the value, the kg value that was wanted, and what is the value that we got from this measurement. So these are the typical cases where measurement designs are getting used. The AI is getting integrated into different domains. So just to show that how other tools are working now. One good thing with AI happened is that because AI, most of the research started with related with Python scripting. So other tools also like simulation tools are trying to integrate Python uh, into their workflow. Here we are seeing that the HFSS tool that comes from ANSYS, so we can script now with scripting we can use run the software. So ultimately you write a script and the software would be able to make the designs, and we can see here that how it does that. Yes, yeah. So all that knowledge, all that human knowledge that is coming from Python, different modules and all that, and AI, it is getting integrated into simulation tools. They are so that they are faster. They are able to give us the result that we want, and on top of that, AI is getting embedded so that uh, the manual way, the way we were designing the structures, it would be much more faster. Another thing is that because GPU is getting cheaper due to AI and gaming, so those that benefit is also coming into simulation software, and we are trying to move more and more simulation software. Simulation softwares are trying to get more and more benefit from the whatever is happening into AI domain. Okay. Just to appreciate that normally how complex the designs might be, like even for antenna design something like this where we have our own tool that we made some time back. You can see that so many lines we have to make, and every line has its own functions, and making this type of structures would be much more easier with AI. Like if we are able to make different designs, then we would be able to train the model, and then we would be able to get the giving the output, we would be able to go back and tell that this type of input is needed. So just to give a little bit more background, that we work on lenses where we have curved lenses, flat lenses, and some of these lenses, what happened that we are not able to make some of these lenses. Basically, the lens would be something like this. It would have different dielectric values, like it here we are showing. These are different dielectric values that we need for the lens. So what happened that making this type of materials where different values of permittivities are needed, it was getting difficult. But after 3D printing came into picture, so something like this. So this is our published work where by using 3D printing, what we can do is that in order to make different permittivity material, we can 3D print it and put a sort of pack of like air voids, we call them. The amount of the air void, by changing the air voids we can make the different dielectric material, and with that it becomes easy to make any designs like this where lenses and all that, depending upon if the material, the base material that we use for this lens is that usable or not. So we made some designs like that, you can see. So what is happening now with we made these 3D printed designs, and now we are also integrating AI into it, and we later on I would show that how we use it. So depending upon the air voids, air holes, we can change the different materials. We can make different materials, and here we show that this type of material can be made by 3D printing. The major benefit from the 3D printing is that instead of manual work, something like this, what we used to do is that we would take the material, then we machine them, we assemble or bond them, and then we would test it. And that's how we were getting the product. If do not use additive manufacturing or 3D printing like that. But what happened after using 3D printing? It removed all the other steps that we were going through. So like sourcing material, machining, assembling, bonding, all those things, now it can be handled by 3D printing. So it becomes very interesting that whatever complex designs that you could think earlier, it was very difficult to make them. And now with 3D printing, it becomes very easy. So any designs like this or any design like this, we just need a 3D printer that is uh, that is that provides the necessary material specification that we need, like nozzle size or the type of the material that we need, like ABS, PLA, that type of material. So then we can make any design that we want. So what it does is that we have like we have support material drive nozzles. So what would happen, that nozzle would go on keep on adding the material where we need it. Here we are showing that two nozzles adding that material. So additively we would keep on making the design something like this. If we see the complex design like this, it takes a lot of time to make it in a manual way, but 3D printing it becomes very easy. So any designs like this, they are very easy to make. These are some of the other designs. Okay, so another design that in lenses that we make, lenses or antenna designs for 5G, 6G type of designs. So this lens we call it Lundberg lens. I will not go too much into details, but uh, uh, we would mainly get the grasp that what exactly is happening in this domain, so that we understand. So what happened that this lens, it needs different values of permittivity, like epsilon r is equal to this. So basically it is 2, permittivity is 2 at the center, and as we go away from the center of the lens, its permittivity gets 1. So what happened that because in nature we do not have the material whose permittivity is 2 and goes to 1. So what normally we do, we take a lot of shells of different materials and then we make a lens. So something like this. But the thing is that it is very difficult to get those materials. So normally there are different ways that people do. What they do that they say, okay, let's make it with 3D printing, and by putting different amount of the holes inside this material, we can get the different we can make the lens. Another way is that you take PCB sheet and put the holes inside it, similar way that we made here, and you can make the lens. But the thing is that how many rings to make? Like I can make 6 rings, I can make 20 rings, or I can make 100 rings. That is that is difficult to decide. So there, what we did is that we thought that why not to use machine learning and there is a in machine learning there is a concept named clustering. The clustering, what clustering does is that for a given values, it can show you that where is the centroid. So we had different values, the permittivity going from 2 to 1. What we told it, okay, make 6 clusters out of these values and also tell us where the centroid is. So after clustering, what would happen? It would say that this is the value around which these values are centered. It's something like this, here, 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 here. So we take this permittivity value, and within this range to this range, we make different shells. So in this way, it becomes very easy to decide. Otherwise, we have to run a lot of optimizations, and we need to know a lot of mathematics behind that how these lenses work. All that becomes very easy once we use clustering. And we saw that when we use clustering like this, that the result that we were getting from the previous research and the result that we get from this research, we were very close to it. It shows we were better, but let's assume that we were close to it. And on measurement side also, like we are using AI, that where we make the lenses. So here we can say it's a good design. That in 3D modeling, we have TPMS, triply periodic minimal surfaces. So here we are showing gyroid. This is one of the designs, one of the TPMS. So what we do here, by using this gyroid, we make lens, and here we also measured it. So the main idea is that by using 3D modeling, AI, measurement, all those things are coming together in order to give us better design, faster design, cheaper designs, where the resources are much lower than what we needed earlier. This is introduction to just CAD and all that. I think maybe we can skip this. If there would be any questions after this, we can handle it. So it's like something designs like this. We use different type of in the past we were working on if somebody has worked on 3D modeling, we have like geometric modeling kernel. We were working on geometric modeling kernel also, so that we can use different type of file formats. This is one of the file format STL that is used in 3D printing, and depending upon the sizes of these triangles, if it is low, then we can get higher resolution structures. And STL file is something like this. We have 3 vertices, and by 3 vertices we make one triangle. And by combination of all those triangles, you can get anything. And here, by combination of these triangles, we get a geometry, a complex geometry like this, and then we 3D print it. So eventually, how the world is going, just to show us that where we are, we because we make our own softwares also. So here we are showing that in order to make any lens like that, what we would need is that, okay, tell me that how many shells you need, what is the frequency or what is the gain, and AI would be able to make you design. It will say you, okay, this is the design, this is how it looks like. And if we have more software capability, it would even run the simulation in order to show you that this is what I predicted and this is what you would get. So this is how the world looks like to us, at least to the antenna designer. Thank you very much. And this is our website. If anybody has any question, they can also email here. And thank you. Thank you very much. Any questions?
Any questions from the audience?
Thank you so much, sir. Now I request Dr. Budhesh Kaur, Head of Department Artificial Intelligence and Data Science, PIET, to please come and present a memento as a token of appreciation to our chief guest, Professor P.C. Pancharia.
Thank you, ma'am. Thank you, sir. Now, I would like to invite Dr. Uday Pratap Singh, Deputy HOD, Admin of AIDS Department, PIET, to come forward and present a memento as a gesture of gratitude to our guest of honor, Dr. Ankit Agarwal.
Thank you so much, sir. Now I would like to call upon Ms. Alka Rani, DYHOD of Academics, Artificial Intelligence and Data Science, PIET, to join us on stage and present a memento to Dr. Basant Agarwal.
Thank you, ma'am. Thank you, sir. Now, I request Dr. Sandeep Gupta to please come and present a memento as a token of appreciation to Dr. Poonam Ghera.
Thank you, ma'am. Thank you, sir. Now I request Ms. Bhavna Purohit, Assistant Professor, Artificial Intelligence and Data Science, PIET, to please come and present a memento as a token of appreciation to Natasha Badnava.
Thank you, ma'am. Now I request Dr. Priya Mathur, Professor, AIDS Department, PIET, to present a memento as a token of gratitude to Nicole Hunevich.
Thank you so much, ma'am. Moving forward, it is our honor to welcome our guest of honor, Dr. Ankit Agarwal, Research Professor, Department of Electrical and Computer Engineering, McCormick School of Engineering, McCormick School of Engineering and Applied Science, Northwestern University, who has been featured in Stanford Elsevier's list of top 2% scientists worldwide. He was awarded the Nano Combinatorics grant for AI-driven nano combinatorics for accelerated structural characterization and co-awarded as NSF grant for explainable artificial intelligence for science and engineering. Citing the same, I would like to invite Dr. Ankit Agarwal to offer his valuable insights.
Thank you. Hello, everyone. And thanks to all the organizers and the entire organizing team for this kind invitation. Uh, uh, as already introduced, myself Ankit Agarwal. I am a research professor at Department of ECE at Northwestern University. And today I'll be talking about some of the work that we have been doing on the integration of AI and HPC for accelerating science, which is very coherent with this theme of the conference um, uh, on recent advances in AI and computer vision smart systems. So these are my team members here and all the collaborators. So being a computer scientist, I actively collaborate with a lot of domain scientists like material science, healthcare, and so on. And these are all the funding agencies that have supported my work over the last decade or so. So this is not moving forward. Akshat. Okay, good. Thank you so much. So this is an overview of the kind of work that I do and as a group as a whole. In this era of big data, I strongly believe that there are these two fundamental technologies of computer science, AI and high performance computing, that need to be integrated more than ever before if you want to solve the big data challenges. So that's what we do in our lab. We call it AI and high performance data mining. And then we also apply it in different domains like materials, healthcare, and so on. So today I'll be talking mostly about the application of AI in the materials domain, how AI can be used to accelerate material science and engineering. These are some of the research projects that I've had an opportunity to work on. I am co-leading the AI tool group at this NIST Center of Excellence, CHIMAT, which is a $60 million 10-year center of excellence. And there is this Air Force Muri project, DARPA project, some NSF projects. And lately there has been also a lot of interest from industry. A lot of companies have approached us to try to learn and adapt these AI technologies in their workflow. So this is going to be the overview of my presentation. I'll start with some overview slides on paradigms of science and the integration of AI HPC. And then I'll give some examples of how we apply AI for the big data problem and the small data problem, because both of these are challenges, right? It's when you have too much data, that's also a problem. When you have too little data, that's also a problem. So how to adapt technologies for that. So this is one of my pet slides. It's almost a decade old now. If you see how science and technology has evolved over years, not just centuries, we can very clearly identify these 4 paradigms of science. Right? So in the beginning, everything was purely empirical. You look at the sky, look at the things around you, and that's the empirical branch of science. Today, it is famous as the experiments, experimental branch of science. Then when calculus was invented in the 17th century, we could take real world phenomena and express them as laws or mathematical equations. And that gave rise to the second paradigm of model-based theoretical science. So laws of thermodynamics or Newton's laws of motion, those are good examples of the second paradigm of science. Then in the 50s, when computers were invented, we could take these equations, because these equations get very big, and the systems of equations get big very, very quickly. So to solve them analytically is not very straightforward. So when computers were invented, we could now solve these big systems of equations, and that gave us the ability to do simulations. So all these weather prediction, climate simulations, material simulations, these are examples of the third paradigm. Then over the last 20-30 years, just the data that has been collected from these first 3 paradigms, that has far outstripped our capacity to make sense of it. So even as computer scientists, we have become very good at generating data, in storing data, in retrieving data, but when it comes to analyzing that data, our capacity is very limited. So that's where this 4th paradigm of data-driven, or AI-driven predictive analytics clustering, that has become very popular, because we are generating more data than we can process. So how to extract insights out of it in a meaningful way, that's the challenge here. So needless to say, it's a very challenging problem. It's like finding needle in a haystack, and I like this example very much, because it not only says that it is difficult to find the needle, it's definitely difficult to find a needle, but it also says that it is easy to find the wrong needle. What that means is that if you're not very careful, if you just take some AI technology, some AI algorithm, and nowadays it's very easy to just go on, on GitHub, download some repository and take some data and put it together. If you're not very careful, if you don't really know the fundamentals and the strengths and limitations of these techniques or data for that matter, then it is difficult to ensure accuracy. So you may get some results, because these techniques will always give out some numbers. They'll take in some number, they'll give out some numbers, but if you're not very careful, we can fall into this trap of wrong needles, and we'll come back to that. So what is AI? AI is the ability of machines to perform tasks that normally require human intelligence, and this is taken from this DoD AI strategy. I'm sure everyone has seen this kind of diagrams where deep learning is a subset of machine learning, is a subset of AI, and there are different ways we can classify these techniques. I particularly like this weak, strong, and super AI. And interestingly, everything that we have today is an example of weak AI, which means that we can make an AI system which is almost as good as humans, or even better than humans, for one particular task. So we can do autonomous driving, maybe we can do game playing, you can make an AI which can defeat the best chess player, best Go player, and all that, but it cannot do everything else the human does. That would be strong AI. And super AI is beyond that, all the sci-fi movies that you see where AI takes over the world. So fortunately, that's not happening anytime soon. Although if you're following this field, you probably know that there is a lot of concern growing with the generative AI, LLMs, and ChatGPT kind of models, that the pace of advancement is far too much and there's not enough regulation. So like with anything, AI can be used for good and bad, and there are increasing calls on how to regulate how to use AI and how to do it in an informed and responsible way. So that's a big area of research. So what we do in our lab is try to integrate these two fields, so AI and HPC, to solve this big data challenge and accelerate scientific discovery, where HPC drives our AI and data mining algorithms, and that in turn drives discovery. So we'll focus on one example, example of one field in material science. And I'm not a material scientist by training, but I've collaborated with lots of material scientists over the last 10 plus years. And if there's one thing I've learned from them, is that almost everything in material science depends on these processing structure property performance relationships. And this is very core and in other fields. So I did my PhD in bioinformatics 15-20 years ago, and there everything depends on sequence structure function relationship. So you have a DNA sequence, then a protein sequence, and a protein structure and protein function. So pretty much all bioinformatics revolves around that, how to understand those relationships. So here everything revolves around these processing structure property performance. So the science goes from left to right. So you can imagine that processing is the cause and structure is the effect, right? How you process will determine what the microstructure is. Similarly, structure is the cause, property is the effect. So science of cause and effect goes this way. Engineering of goals and means goes this way. So if your goal is to have high performance, the means to achieve that goal is to work on the processing, work on the structure. Right? It's very straightforward to understand. But interesting thing here is that these are many-to-one relationships. So within the processing space, there could be many different processing routes that give the same structure. Theoretically, it's possible, right? You can have different ways to process a material at different temperature. You can heat it, beat it, stretch it, and all that. And you may get the same structure with multiple processing. Similarly, you can get the same property with multiple materials. But the inverse, for a given material, like let's say this in this structure phase, there is only one property. But for a given property, there can be many materials. So this forward problem is relatively easier because for one input, there is only one answer. For a given material, there is only one property it can have in most cases. But if you want to discover a material with a particular property, there could be many different materials, and your job is to identify or discover the best one, because best may be defined with respect to other properties or how easy it is to manufacture in the lab and so on. So this inverse problem of optimization is much more difficult. And you can imagine that if you had all the power in the world to do this forward problem. So what AI can do is to help us in these forward models, where we can express this property as a function of some representation of material. So given a material, you just put this material in this function and you get the property. That's what an AI model does, a forward model does. And because these models are very fast and hopefully accurate, they can help in this inverse model. So imagine you can do all the experiments in the world. You can design all the materials that you can think of, which are infinite. But if you can really do that, you can identify the best one very quickly, right? So that's what AI can enable, because if you can do this forward model very fast, you can try many more realizations of the potential candidates of materials, and then you can find the best one very quickly. So all this I discussed in this review article from a few years ago that you may be interested. If you are, you are welcome to take a look. So with that, a little bit of overview of how we apply AI for the forward and inverse problem. I'd like to give some examples of how we apply it for big data and small data problems. So when the data is big, of course, everyone here has heard of the term deep learning, how it has revolutionized the field of AI in the last decade or so. And the way it works is it has input layer, hidden layers, output layer, and the strength lies in the number of hidden layers. So if you have a very large number of hidden layers, then it's a deep learning network. So if deep learning is so great, why not go for deeper learning, right? So why not just increase the number of layers to whatever you want? Unfortunately, that doesn't work so well, because like if you see here, this is a error versus iterations or training epochs curve. And if you have a 17-layer network, this was some work that we did in 2017-18 called LMNet model. This is the curve. When we make into 24 layers and 48 layers, the error actually increases instead of going down. And that has to do with the fact that there is something called this vanishing gradient problem, that as you increase the depth of the model, the training can halt, because the way these networks are trained is that you backpropagate the gradient of the loss with respect to the weights. And if the network is very deep, you can halt training very easily, because they can either, the gradients can die out or they can explode. So a few years ago, one of our students developed this idea of IRNet, individual residual learning, based on the ResNet idea for images, where we had these individual residual, these skip connections after every network. and that helped improve the accuracy a bit. So from like 41 electron volts, you could actually improve it a little bit. And then when we tried with 30 different data sets, we found that there's a nice relationship here. So here the y-axis is the relative MAE. So anything on the x-axis is the MAE of the best machine learning model that we had at that time, 2019. And anything above that means this proposed model is worse. Anything below this means the error is lower. So we can see that when the data is very small, then you're better off with traditional machine learning. Decision trees and random forests and those kind of things, XGBoost and all. But when you have enough data and around 20,000, so if you have around 20,000 data points, then you can take advantage of this individual residual learning idea. And this work was presented in 2019 in KDD, which is one of the biggest conference. And we have followed it up over the years with branch residual learning and different additions to this. That you are welcome to take a look at these papers. In red, I'm highlighting the computer science conferences, and in green are the domain or materials journals. So we try to publish in both. So that's one thing we can do. When you have big data problem, we can use deep learning and deeper learning if applicable. Another thing we can do is use HPC. So we can use a lot of compute resources, aggregate them, and increase our throughput. So this is one example of parallel CNN training. CNN is, of course, everyone knows, is a very useful network for images, convolutional neural network. And the way it is trained, even in parallel, is that when you have this training data, you give a mini batch at a time. And if you want to do in parallel, you break the mini batch into, let's say here, 4 parts. And then each processor will do its own thing. And then with inter-process communication, you combine the results. So if you have a large batch size, then you can do parallelism easily, right? So you can have more parts. So if you have more processors, then it is easy to parallelize. But that comes at the cost of accuracy. So here you see this is accuracy versus time now. If your batch size is small, then you have a high accuracy. But if your batch size is large, 256, then your accuracy is not that much. So either you can get good speed up or you can get good accuracy. So it's difficult to get both. And that's where one of our students, they applied these, a series of ideas, but here I'm presenting this adaptive mini batch size adjustment. So whenever you have a trade-off like this, accuracy and speed up or scalability trade-off, you have to try to find the best of both. So what we did here is we start with a small batch size and gradually increase to get a good trade-off. And then we found that when we did that, we got speed ups of up to 81 on 128 nodes, which means that the training that used to take more than 4 days could now be done in less than 1.5 hours. So that means you can try more models, you can get your best model much faster. And this is an example of image super resolution with the same accuracy. So you're getting scalability, but you're also getting the same accuracy. This gray curve, it actually converges to the same accuracy as the small batch size of 16. So this is another way how you can tackle the big data challenge by using advancements in AI front as well as advancement in the HPC front. And that's what we try to integrate in our lab. When we come to materials applications, however, the challenge is more of small data rather than big data. Many fields have millions or billions of data points, but in materials, big data is very rare. There are some data sets which have millions of data points, but experimental data is very small because it takes time to build the material and a lot of cost is involved and all that. So the small data challenge is much more prevalent. So some techniques that we have done to tackle that challenge is deep transfer learning, for example. This is one of very commonly used technique now, where if you have a small target data set that you want to build a model on, you don't directly build a model. If you directly build a model, we are calling it the scratch, training by scratch model. But you start with a big source data set, which is a different data set, and then you build a model on that, and then you try to transfer that knowledge during this model training step. And this transfer of knowledge can be done in 2 ways. One is fine tuning, where you use the source model as your initial weights, and then you just fine tune. Instead of starting with random weights, you start with these source model weights. And this is the normal way by how transfer learning is done. But another way you can do is you can extract features. So you can use this model to extract features on this data set. And hopefully these features will be more informed. It has learned a lot of domain knowledge from this learning process. And hopefully these features are more informed, and then you can build a new AI model on top of it, any algorithm of your choice. So a few years ago, we tried it in the context of same property. So if you have a experimental formation energy data set, which is small, you can use a simulation formation energy data set as your source model and then transfer the knowledge. So here we find that when we did that, we can get up to 50% better accuracy or 50% lower error with the transfer learning model. And this work was published in Nature Communications 2019. And then we followed it up with a cross property, because what happens if you want to make models on properties for which the same property is not available? If it's available, great. But if it's not, then what can we do? Then we found that instead of fine tuning, this feature extraction idea is still valuable, at least for some properties. So we tried 39 different properties, and we found that the transfer learning model was better than the scratch model in almost all the cases. And even when the scratch model, which is just training as it is, even when that was made more powerful by addition of physical attributes, even then we could the transfer learning model was better in more than half of the cases. And it also had great extrapolated potential. So here you see that in this regime, training was only done in this domain, and when you test in this domain, it's great. You know, both the models are good. But when you go outside it, so extrapolation is a big problem, right, in machine learning. And for this formation energy, we want more negative values. More negative values means more stable. And we find that this transfer learning model is still accurate, although the scratch model is not. So that was another Nature Communication paper a few years ago. And then we followed up with the integration of GNNs and LLMs in this most recent work from a few months ago in digital discovery. So that's one way. Another thing that we can do for inverse design is this generative AI, where you use GANs and MDNs to discover new materials. So you can use GANs, as you probably know, that there is a generator and discriminator, and if you have these original images, it can generate realistic images, and if you apply it in a optimization loop, you can get very quickly fast new materials in a fraction of time. So these are some works that are recently published in these conferences and journals that you can take a look. The last example I want to show is of industry. So as I said, a lot of industry interest is there nowadays to adapt these techniques. So a few years ago, we were approached by Toyota Japan, and this is part of the work that we did with them that I am allowed to share, because there is a lot more under NDAs and all. But this is published work, so I can share this. So you can imagine that any big company like this will have a typical processing workflow where you start with some materials and there's a series of processing steps, and you can measure the property at different points. And the goal is to predict these properties and then inform the design process. So this is experimental data, very small, heterogeneous, noisy. So we again use this transfer learning idea, where we combined both the images, the materials images from SEM and all, as well as the numerical data like composition, alloys and all. And with this pipeline, we concatenate the representations from the VGG extracted vectors, as well as the numerical data. And then by training a XGBoost model on top of it, we found that we can develop models with less than 5% prediction error for both these properties, coercivity and remanence, which are two of the most important properties of magnets. And then that was actually a game changer, because the ability to predict these properties accurately early in this workflow can help these companies to save resources on unpromising candidates and only spend resources on promising candidates. So that can help avoid high-end processing and reduce SCM man hours and save a lot of money. And then that in turn can help in directing the resources in the right direction and discover the materials faster. So again, more details in this paper that you can take a look. This is a summary of the works that we have done in AI for materials in the last 10 years or so. As I said, a lot of work for forward prediction models. So again, given a material, what is the property? And the inverse models, which means given a property, what is the material? And then structure characterization I've listed separately because it involves images and it has some features of both forward and inverse models. And there are also a few review and perspective articles that you can take a look. As I said, CS publication in red and domain in green. Also a lot of open source tools and software available. If you go to this website, you'll find tools like this where you can put a material of your choice and you can get the predictions of those properties very quickly. As well as open source code available in GitHub that you are welcome to build upon. So with that, I would thank you for your attention and happy to take any questions. Thank you. Any questions? Feel free to reach out. This is my email if you want to. Yeah. Thank you.
Thank you so much, sir, for sharing your insightful thoughts with us.
Let's welcome Dr. Basant Agarwal, Associate Professor at the Department of Computer Science and Engineering, Central University of Rajasthan. With over 10 years of experience in research and teaching, Dr. Agarwal's expertise lies in developing AI-based tools and applications using NLP, image processing, machine learning, and deep learning techniques. He has held prestigious positions at Norwegian University of Science and Technology and National University of Singapore and has worked at Triple IIT Kota. His research interests and experience make him a distinguished expert in his field. Sir, we are deeply honored to have you here with us today and we invite you to grace the stage and share a few words with us.
Okay. Hello, everyone. Uh, Myself, Basant Agrawal. I'm working at Central University of Rajasthan. Firstly, I'm very thankful to Professor Dinesh Goyal and Madam Budesh for inviting me for this keynote session. And I'm very thankful because in the last moment we discussed only yesterday that we want to attend the conference and we are here. So thank you very much, sir and madam. And my presentation, when I was thinking about what I should speak on this keynote speech moment, that firstly I would like to give one message. My presentation will be very short, but I will be giving you two messages mostly. First, as a young student, based on my experience, I will give you a suggestion that you should all give your efforts for on a project which has some impact. Impact maybe in the terms of if you are working on a research project, it should be useful for the society, and if not, then it should be useful for the industry and useful for making some money or maybe commercial use. So working on a project which has no use, and it is just a project which is in the pen drive and you can just cap and then return a report and then forget. So my suggestion is you just choose the project wisely and then give your effort and time like on that project. So that is very important. That is one of my suggestion to all of you. And one of such project which we are doing with the funding from Department of Science and Technology, Government of India. I would like to use this platform to give you awareness about this dysgraphia, what dysgraphia is, which is very important thing, which you might have heard, but I'm sure a lot of people don't know about it, which we are working with the Government of India, and that is very important problem which we see in the society. How many of you have heard about dyslexia? So Tare Zameen Pe, the movie that made it popular, dyslexia, but dysgraphia is another problem which is very similar to dyslexia, which is in the small kids. So you see the handwriting which is written on the right hand side of the screen, which is written by a student of age 6, which is having a problem of dysgraphia. So a person who is not able to write properly and because of their neurological disorders in the mind, is not able to write properly. So when we see the student in our
the kids or early age students, some of the students, the teachers, even parents, they don't know about this problem, and the student face a lot of problems. So what we are trying to do is we are trying to develop a mobile app and the software which can be used by the teachers and parents that they can use to find out the students or the kids which may be at risk for the dysgraphia. So that is what our aim. I will quickly go and give you an idea of that what we are trying to do. So my key points of this presentation is to give you an idea that what is a dysgraphia and what we can do about it, and what we should know about it. Okay, so these are more examples which we can see and observe that these samples are written by students with the dysgraphia problem. Dysgraphia is not a disease. This is not a, actually I should not say it is a problem, but it is a symptoms which is which we, if we also observe among the kids, young kids. So this problem cannot be cured, but it can be helped with the clinical psychologist, and the student, because of this problem, he will or she will not be able to write correctly. So that comes under one of the learning disability problem. So these are 5 other learning disability problems, but I'm focusing about the dysgraphia, and I'll just quickly go this. So one of the important thing which I have observed during our research and analysis is just a story that we have heard from one of the parent, that a student, like a kid, he was not able to write capital letters even when he grew up. Even one of my student in the BTech, he was having this problem and he could not even write capital letters from his, even if he was trying. So that is a problem which is vigilant very much in the society, but we don't know about it. I'll show you some statistics also that how much people have this problem, and the major problem is that we don't know about it. So these are more examples you can see, and I'm sure that you will be able to, if you will focus these samples and examples, you can see that what are the symptoms. So what we are trying to do is we are trying to develop image processing system which can automatically detect those patterns and the symptoms. So for example, the words written by dysgraphic student is they will use irregular capital letters, they will use irregular spacing between the words, they will use on the slanting heights, or they will not be able to write in the straight line. So these are the common symptoms. There is a long list, but because of the time I will just want to give you an idea. And one of the major important symptom is write the words in irreversible, like reversibly. Like for example, mirror in a mirror image, M is they will write N. Okay, so P they will write as a Q, and so on. I'll give you more examples also later. And okay, so these are some statistics. You can see that there is large number of students in the schools, and approximately 15% of the students face this problem, and only 2% of the students that are detected. And just because of the awareness among the students, parents, and the schools and the teachers. So that is the main problem, and I am using this opportunity to give you some awareness for those who don't know about dysgraphia. So the thing that you should keep in mind is that about dysgraphia is, if you are, if someone is having bad handwriting, so it means 2 things. One is genuinely the student is handwriting is bad, but reverse is not true. So if your handwriting is bad, it doesn't mean that you have dysgraphia. But if your handwriting is bad, it means that even if you are trying, but you are not able to write correctly, so you should see these symptoms and then consult the doctor. And we should not force the young kids for practicing and then revising and then trying to improve their handwritings. I will show some example, and I will also discuss some cases which we have observed when we visited different schools while collecting the data. So this is we visited several schools for collecting the data, and we observed, and with different exercises we have collected the data. And what we have observed, these are exercises which we have developed with the doctors and clinical psychologists, and we have observed many interesting observations in the schools. So one of the student in one school, I just let you know one story about our experience in one of the school, that one girl was, when I was studying in the school, and the one exercise we are doing while data collection. So fifth standard girl, she was when after dictating in the exercise, so one of our volunteer was trying to speak some letters. So the girl was not able to hear properly. She was just looking to the neighbor's copy and then trying to write. And whenever she was not even confident that whatever she has written was correct or not. So fifth standard student, then we talked about her to the principal and teachers. So they said, okay, so this student is, because the school was having extra classes for the students who has bad handwriting. Then we discussed that okay, this is a possibility that this student is having some similar kind of problem, and they consulted and then find out, okay, this is that student is needing some assistance from the clinical psychologist. This is not a problem, this is not a disorder, but this is a situation where we need help. Okay, so this is sometimes parents see this as a stigma, but this is not that case. A lot of big names has this kind of problem, but yeah, so this is a situation which we should be aware about. Okay, so these are the examples. I'll quickly go with this, and then we have developed methodologies for identifying these automatically from the handwriting images. Existing models, they use hardwares. A lot of research is going on to ask the student write on the hardware, but we are focusing on images, directly on images. We just click the image and then upload on our server, and then we can find out, okay, this student is having a chance of having the dysgraphia or not. So standard procedure we are following, we are extracting features, different features. I'm sure, sorry, this name of the features is not visible. So baseline feature, pressure, slant angle, letter size, line spacing, word spacing, spelling errors. So all these features we are extracting from the image of the dysgraphic and non-dysgraphic students, and then applying different machine learning algorithms. I'm sure you are aware of the standard procedure. And so these are some examples on how spelling mistakes people do. And then these are different features which we are trying to extract. And these are the standard procedures which we are following. And then we also develop multiple models like VIT, vision transformers, and then also use different way of doing ensembling models. So yeah, I'm not going into those details. I'm sure that is that is already known to you. So yeah, so in the VIT we thought like, okay, the images are not all the part of the images is important, so we divide the image and then see which portion of the image is important, and we use those patches. And then we also use ensemble learning models, and then see that we observe that the overall performance of the model is better. So thinking about the time constraints, and I'm not going into those details. If you search on the Google, so you will find our papers which is related to the work which we have done on the dysgraphia detection using machine learning and deep learning algorithms. So these are some of the results, and our model with the VIT and ensemble modeling, we could get up to 98% to 94% of the accuracy on the data which we have developed with visiting the schools and the clinical psychologist. Okay, so this is some of the prototype which of the mobile app which we have developed, and this is the app screenshot. You have to just select the image, to click on the image, select the image, upload, and we have different models. You select the model, and the outcome is like it is suggested if you are at risk or not. Okay, so these are the videos. I am not sure if we'll be able to run Yeah, okay, it is working. So how to use this? So tild.co.in is our website of this project. You can just explore and see that the performance also you can see that okay. So if I upload an image of the dysgraphic student, so it is saying okay. So yeah. So this is a mobile app, and this is the website which we have developed. With the website is also having the online portal where we can directly collect the samples from the parents if they want to share the data. This is the team web with which we have worked. Okay. Yeah, so our project website is tild.co.in, and with this I am thankful to all of you for hearing me so nicely, and if you have any questions, please let me know. I will be happy to answer your queries. Yes, madam.
Accepted or how the model will be turned because it's a new thing.
Yes.
Definitely with new research and new things, it has to be trained.
So what we have done, madam, very interesting question. Actually, we faced almost 1.5 years on how to develop the model because it's a new thing and no one has the data. So we are the first who has developed this data. All the existing data, all the research which is being done on this problem all over the globe, they are using hardware, and we wanted to make a like a scalable solution. So for that, we visited almost all the clinical psychologists and also on the internet, which the images which are free, and we could provide 200 dysgraphic images, madam. So students who has a dysgraphic problem, we have images of approximately 200, and then with data augmentation, we increase the sizes. And by visiting the schools, we asked the students, like we excluded the sample with those handwriting was bad, and only good handwriting students we have taken as a normal non-dysgraphic students. So images of the non-dysgraphic images and dysgraphic images both as used for the training the model, and we have extracted different features like for that. So the non-dysgraphic student, what I'm saying is, if a student is having not bad handwriting, it means that the student is non-dysgraphic, and reverse is not true. So when we are visiting the schools, the students we have identified, okay, this is 1,000 student samples we have collected. We have manually seen this student is not, it's not bad handwriting. So we have taken, otherwise we are excluded. So we are sure that this is non-dysgraphic students. And for the dysgraphic students, we visited doctors and clinical psychologists, and we have taken the samples from the parents or the doctors. So that way we have ensured that all the images are. Yes, sir. The speed of writing is also, but we are not using that because that can only be collected with the hardwares. Yes. So that is not a feasible solution. Scalable solution is not. So otherwise they use pressure, what is the angle, a lot of things are there. But what we are trying to do is we are trying to develop model without these features which is depending upon the hardware. Any other questions, please? And you can reach me to with this email ID, and you can search. Any other questions, please ask. So thank you very much once again, and again thank Dr. Dinesh for inviting me for this.
Thank you so much, sir, for sharing your inspirational words with us. With sincere appreciation, we would now invite Dr. Uday Pratap Singh, Deputy HOD of Artificial Intelligence and Data Science PIET to propose the vote of thanks, bringing this inaugural ceremony to conclusion.
गुड मॉर्निंग, कैसे हो सारे? ओके, फाइनली वहाँ वेट ओवर हो रहा है. आई एम गोइंग टू डिलीवर थैंक यू नोट. एंड फर्स्ट ऑफ ऑल आई लाइक टू थैंक आवर चीफ गेस्ट डॉक्टर PC Pancharia sir and Valentina ma'am, esteemed guest of honor and keynote speaker Dr. Ankit Agrawal sir, our honorable session chair Dr. Poonam Gera ma'am, director sir, registrar sir, distinguished researchers, faculty members, industry professionals and students. As we conclude the inaugural session of Second International Conference on Recent Advances in Artificial Intelligence, Computer Vision and Smart System, ICRACS 2025, I stand before you with immense gratitude for making this opening ceremony a memorable one. I would like to express my heartfelt thanks to our chief guest, Professor Dr. PC Pancharia sir, for your gracious presence and inspiring inaugural address. Your insight from your distinguished career at CSIR have set an excellent foundation for the technical session that will follow. Our sincere appreciation goes to Dr. Ankit Agrawal sir, our guest of honor, for your enlightening keynote address that has given us valuable perspective on the cutting edge development in AI and data mining. Your recognition among the top 2% scientists worldwide is truly inspiring for all of us, especially our young researchers. I extend my special thanks to Dr. Poonam Gera ma'am for accepting our invitation to chair our upcoming session. Your expertise in privacy framework and blockchain applications will undoubtedly enrich our technical discussion. My thanks also goes to our institutional leadership, especially Director Sir, Professor Dr. Dinesh Gul Sir, and Registrar Sir, for their unwavering support in hosting this international conference. I must acknowledge the organizing committee members from the Department of Artificial Intelligence and Data Science at Pune, whose meticulous planning has ensured the smooth execution for the inaugural. I also like to thank all the students who have helped us to organize this event, and last but not least, not the least, to all the authors who have submitted their research papers, and we look forward to your presentations in technical sessions over the next 2 days. Finally, I thank each and every participant present here today. Your engagement and promise to make ICRACS 2025 a platform for meaningful exchange of ideas and collaboration and opportunity is thankful. Thank you so much.
Thank you, sir. Thank you, everyone, for being patient and being with us today and making this event so successful. Now, we shall request everyone to proceed for lunch, and we will resume for technical sessions at 1 p.m. Thank you. Everyone, kindly please be seated. We'll have a group photograph, and then everybody can leave. Students, please be seated. Let the guests leave first. I request all the faculties to go outside of the seminar hall for the group photograph. Students, please be seated. Students are not yet allowed to go out of the seminar hall. Let the photograph be happen and then you can leave. Students, kindly wait for a minute.